When we gaze up at the night sky, we see a canvas dotted with stars, each a distant sun, many with their own planetary systems. For centuries, humanity has wondered, are we alone? And if our own Earth were ever threatened, could we find a new home among the stars? This train of thought leads us to what some scientists call Plan B, the search for habitable planets beyond our solar system. The search for these worlds, known as exoplanets, has advanced dramatically over the past few decades. Early astronomers could only speculate about other worlds. But today, thanks to powerful telescopes and innovative techniques, we have confirmed the existence of thousands of exoplanets orbiting distant stars. Yet, among this vast array of alien worlds, only a small fraction might resemble Earth closely enough to be considered potentially habitable. But what does it mean for a planet to be habitable? Scientists look for several key factors. A potentially habitable planet must be rocky, not a gas giant like Jupiter or Saturn. It must orbit its star at just the right distance, what astronomers call the habitable zone, or Goldilocks zone, where temperatures could allow liquid water to exist on the surface. Water is essential, as it's the solvent for life as we know it. The planet should also be large enough to hold an atmosphere, but not so massive that it becomes a mini Neptune with crushing pressures. The first exoplanet discovered orbiting a sun-like star was 51 Pegasi b, found in 1995. It is a gas giant, not suitable for life as we know it, but it opened the floodgates to a new era of discovery. Since then, missions like NASA's Kepler Space Telescope have identified thousands of exoplanets, many of which are rocky and orbit within their star's habitable zone. One of the most exciting discoveries came in 2015, when astronomers announced Kepler 452b, a planet about 1,400 light-years away. Kepler 452b is about 60% larger than Earth and orbits a star very much like our own Sun. It lies comfortably within the habitable zone, where conditions might permit the presence of liquid water. While we don't yet know if Kepler 452b has an atmosphere, or life, it stands as one of the most Earth-like exoplanets discovered to date. Another tantalizing system is TRAPPIST-1, located just 39 light-years away. This ultra-cool dwarf star hosts at least 7 Earth-sized planets, 3 of which orbit within the habitable zone. Because they are so close to their parent star, these planets complete an orbit in just a matter of days. The proximity of TRAPPIST-1 to Earth makes it a prime target for future telescopes, which could analyze the atmospheres of these planets for signs of water vapor, oxygen, or even potential biosignatures. Proxima Centauri b, orbiting the closest star to our Sun, is another compelling candidate. Just over 4 light-years away, Proxima b is about 1.3 times the mass of Earth and lies within the habitable zone of its red dwarf star. However, red dwarfs are volatile, with frequent flares that could strip away a planet's atmosphere, making the long-term habitability of Proxima b uncertain. Further afield, scientists have identified planets like LHS 1140b and Ross 128b, both rocky, both found within their respective habitable zones, and both orbiting stars relatively close to our solar system. Each discovery brings us closer to understanding how common Earth-like planets might be in our galaxy. But finding a planet in the habitable zone is just the beginning. The next step is to determine what these worlds are really like. Do they have thick atmospheres that could support liquid water? Are there clouds, oceans, or continents? Could there be life, even if it's just simple microbes? To answer these questions, astronomers are developing new tools. The James Webb Space Telescope, launched in December 2021, is designed to peer into the atmospheres of distant exoplanets, searching for the chemical fingerprints of water, oxygen, methane, and other molecules that might indicate life. Meanwhile, ground-based telescopes like the Extremely Large Telescope in Chile will offer unprecedented resolution, allowing us to study these distant worlds in greater detail. Imagining life on these planets is a fascinating exercise. Some might be water worlds, covered entirely by global oceans. Others could have thick, hazy atmospheres like Venus, or surface conditions that are alien and yet familiar. The length of their days and years, the color of their skies, the brightness of their suns, all would shape any life that might evolve there. The search for habitable exoplanets is not just about curiosity, it's also about survival. As Earth faces growing environmental challenges, the idea of a backup plan, a Plan B, gains urgency. While interstellar travel remains beyond our current technology, understanding where habitable worlds exist is the first step toward a future where humanity might one day journey beyond our solar system. Yet, Even as we scan the sky for new homes, it's clear that Earth remains uniquely suited to our needs. No other planet so far has offered the perfect combination of conditions that make life possible here. Plan B is inspiring and important, but it also reminds us of the preciousness of our own world. The ongoing search for habitable exoplanets continues to rewrite our understanding of the universe. Every discovery raises new questions and possibilities. Are we alone, or is life common among the stars? Could we one day visit, or even settle, on another Earth? With every new telescope, every new world found orbiting a distant sun, we take another step closer to answering these profound questions. In the end, the search for Plan B is as much about understanding ourselves as it is about finding a new home. It challenges us to look beyond our own horizons, to imagine what might be possible, and to cherish the planet we call home. As we explore the cosmos, let us remember that, for now, Earth is not just our only home. It is the best home we know.